In this video, I'm going to show you how to find the eigenvalues of a 3 by 3 matrix, in this case, matrix B. Recall that eigenvalues can be found if we solve this characteristic equation. Let me show you what this characteristic equation constitutes of using this matrix B. So this means determinant, so I'm going to take the determinant of the matrix B minus lambda. Lambda is the eigenvalues that I'm supposed to solve, so it is unknown. And then you have I. I stands for identity matrix, which means that the diagonal elements are all 1 and the other elements are all 0. So I chose a 3 by 3 identity matrix in this case because this is a 3 by 3 matrix subtraction. So let me close the determinant and I must equate this to 0. So if I were to do this matrix operation, I have 2 minus lambda 1, 0 minus lambda 0, and so on and so forth. This center element, I have 1 minus lambda times 1. So this element, I have 1 minus lambda 0, and continue in this manner. So now I have to solve this 3 by 3 determinant. I'm going to use cofactor expansion or Laplace expansion. I'm going to use the first row as my reference of expansion. So I have 2 minus lambda. Take away the row, take away the column. I have 1 minus lambda followed by 1, followed by 1 and 1 minus lambda. And since this is 0 and this is again 0, so there's nothing for me to write after this. So let me just have to simplify this part. This is now a 2 by 2 determinant. I can just take this element multiplied by this element minus this element multiplied by this element. So now you have to simplify this. I have a 1 minus a 1 that will cancel out. So I have a minus lambda and a minus lambda and a lambda square. So let me continue to factorize this. There's a common factor of lambda. So solving this, I have lambda equals to 0 or lambda equals to 2 or lambda equals to 2. So I have these eigenvalues. Eigenvalue can be 0 or 2, and 2 is a repeated eigenvalue.